After going through all that effort to start h2o the really painful way, just to show you the flow, I almost forgot to show you the flow. So here we are in the flow. It's a point and click interface, which to be honest, we're never going to use because it really feels quite clunky. But the idea is that you can point and click your way through analysis, especially if you're uncomfortable writing the code. Let's give it a go. Import files. Now it's even more painful than I remember because I've got to navigate up 9 directories because I can't seem to use home in here. So let's see what I can do. Just noticed that I wasn't recording. Hope I haven't missed out too much. We got as far as wondering why I can't see my data. Okay, I'm finding this quite fiddly to select what I want to select here. Goodness gracious. I'm not quite sure how I fiddled that and why it wasn't working. It was working earlier today. I'm just going to carry on with parse the file. So basically you do get some quite nice stuff here. It goes through, and with a user interface you can choose whether you want things to be numeric, to be this factor variable that we talked about before. I'm going to leave it as it is. I'm going to parse it. It's done. We can view the data, and you do get interesting stuff that kind of describe information that you would get from pandas. I do like that it gives you the cardinality. You can see how many unique different levels there are of each of these enumerated variables. So there are 14 different subclasses, 5 different zones, and so on and so forth, 24 different neighborhoods. Well, what do we want to do next? What we want to do next is to split the variables into train and validation. I'm guessing it's going to be this split frame one. Yep. 75-25 for train and val sounds reasonable. Oops, we need to define what we want as the Amy's house pricing data. Good, so we've now got 2 frames, one with 75%, one with 25%. Finally, let's run a model. Build a model. Now, I actually tried building a generalized linear model because I thought that would be good. That's what we're doing at the moment. I couldn't get it to work. I'm sure I was just doing something wrong. I'm not massively familiar with this interface. I just wanted to show you really that it exists and it works. So here we go. We're going to do a random forest. This doesn't have to make a massive amount of sense to you. I like decision trees, and you might not have come across decision trees, so in which case just think of it as a model. We're going to train it on 75% of the data, validate it on 25%. The response column is the sale price, and the stuff that we want to ignore, well, I want to ignore enumerated classes with lots of levels. It's fine to have missings in random forests. At least I'm pretty sure it's fine. Okay, that should do. The number of trees, let's go for 1,000. We'll keep the max depth as 20. It's funny, I was looking for something which tells me the minimum amount of examples that there are in each leaf. Didn't find it. So I might just change the maximum depth to 10. Let's see what happens. Well, that took a few minutes to create 10,000 trees. Sorry, to create 1,000 trees. Given that we're running on a fairly poor machine with only 1 CPU, I think that's actually really impressive. Let's get the model. I mean, here we have variable importances. We're going to see a lot more about that next week probably, or the week after. But you can guess what it means, which variables are most important. Overall quality is most important according to this decision tree. What I am interested in is the training metrics and validation metrics. How well have we done? Where's the MAE? 14,500. And the validation metric? Well, it's not massively overfitted, which is always kind of quite impressive when random forests do that for you, even though each one is individually very complicated. Overall, they're not complicated. I probably shouldn't be talking about this because we're going to cover it properly. But in any case, that MAE of 15,000 on validation, from memory, that is not really impressive compared to our fairly simplistic elastic net that we did at the end of last week. But still, that's it. This is Flow. It creates code for you which you can then use elsewhere. I'm sure it's a whole lot better than I've made out. I'm just completely unused to it. This is almost the first time I've dived into it, only because I wanted to show you that it exists. I'd be really interested if some of you did look into these. There are some sample flows somewhere. There you are, there's some example flows which you can have a look at. If you do and you find out stuff which is really interesting, post it on Moodle. And otherwise, see you soon.